Welcome back. In our last video of this chapter, we're going to go ahead and add a little bit of graphics to our program. And so our goal is to draw a visualization of that quadrant with one color dot for every dart that lands inside the arc and another color dot for every dart that lands outside the arc. Now, I do want to warn you that this is going to be done in a different way from what the text does. So the things that are in this video and that are in the Jupyter Notebook, which is included in the Canvas site, aren't what the text does. Okay? The text uses turtle graphics to visualize that Monte Carlo simulation, and that's really a bad choice in terms of the amount of work that you have to do to make that happen. Plus, not all of the statements that are included in the text will work with our Colab Turtle module. So we're going to not do turtle graphics. Rather, we're going to use Matplotlib, which is a really powerful plotting module that comes standard with Python. And it's used in all kinds of scientific computing and for machine learning and things like that. So learning about it is a handy thing. It's much simpler for this application. I think if you go and compare our code that we'll end up looking at here in a minute to the code from the book, you'll find that the code that we're looking at is much simpler. And as an extra bonus, it'll work in our Jupyter Notebook. So let's take a look at that modified listing 2.6. Okay, here's what we do. Up at the top, we start with sort of a magic statement that allows us to use Matplotlib in a Jupyter environment. Okay, so this will make our graphing windows, our graphics, show up inside the notebook rather than in a separate window. So Matplotlib inline with a % in front of it. Okay, and I say that's magic because you don't have to worry about why it does what it does. Just know that you have to have it if you're using Matplotlib in Jupyter. Secondly, then, we have our import. So we're importing the PyPlot object from Matplotlib as PLT. That's very similar to the way we imported Colab Turtle as Gertrude. Then we go ahead and configure it. So first of all, plt.rcparams figure.figsize equals 9, 9. And note the square brackets here, not parentheses. This is sort of another magic phrase that's used to just set up a square plotting area. And since what we're plotting is a quarter of a circle, to make it look like a quarter of a circle, it's handy to have our place where we're drawing it be square rather than, say, HD TV size, which might be a 16 by 9. Then we have our function, and this function is really very similar to what we did before. Right? It's named different, show MontyPy rather than MontyPy before. Really the only difference is our drawing commands. If the dart is in the arc, then we plot a blue point. And we do that by plt.plot x, y. So that's saying go to that point, the x, y point. And then the third parameter, this string, b dot, says draw a blue point. Otherwise, now this is different. We didn't have an else statement before because there was nothing to do for darts that fell outside the circle. In our case, there is something to do. That is, we want to plot at that point, x, y, a red dot. So r dot as the color and the shape of the thing that gets drawn. So let's enter that code. And now I can do 100 points and blink. There we go. There's our visualization. It's kind of hard to see, but you can tell that the darts that were inside the circle are colored blue. Let's do a few more. Let's do 10,000. And when this is done, we'll see a much better display of the arc and the non-landing darts. There we go. So everything that's blue was a dot that landed inside. Everything that's red is a dot that landed outside. So there we go. That's an easy way to show the visual progress of our Monte Carlo pi approximation.